Hi, welcome back. This is Ms. McClellan here to go over IM2 Notes 9.2.1 with you, Quadratic Applications with Inequalities. We have two learning goals. Those are that, and I'll write these in the first person, I will be able to, number one, create and interpret quadratic equations and inequalities. To model real life situations. And number two, that I will be able to solve quadratic inequalities using algebraic techniques and graphically. Period. Let's get started. Problem 9-49. Gold Diggers Gulch. During a field trip to the Minor 49ers amusement park, Alfredo notices that a portion of the Gold Diggers Gulch roller coaster is shaped like a parabola. Now, near the base of the parabola, the track goes underground into a tunnel. Okay. A car on the track speeds towards the tunnel from 300 feet above ground and then reemerges above ground 100 feet to the right horizontally. So just looking at this drawing, I'm going to mark some points. Let's see. We're going to have x be the horizontal distance from the start. So that means this is the start. This would be the point 50, 0, and this would be the point 150, 0. Okay, and y is the height of the car in relationship to the ground. So up here is the point 0, 300. Okay. So we're going to write an equation for the path of the car on the track. Okay. Y is equal to x minus 50 times x minus 150. Here I'm using the zero product property in reverse. I know that if I were to solve this equation for my x-intercepts, meaning if y were 0, then it would result in x-intercepts of 50 and 150. So this is a good start to the equation, but I do still need to solve for a. Now in order to solve for a, I'm going to use the point 0, 300 to solve for a. I'm going to take 0, 300 and plug it into my equation. 300 is equal to a times, now when y is 300, x is 0. So a times 0 minus 50 times 0 minus 150. Okay, so if I solve this, I get 300 equal to a times negative 150 times negative 50. That's 300 equals a times 7,500. Divide both sides by 7,500 to get a alone. That gets me a is equal to, if you put this in your calculator, you get 0.04. So my equation is y is equal to, plug the value of a in, 0.04 times x minus 50 times x minus 150. Box it. And we also need to state an appropriate domain for the situation. So just based on what's on this drawing, and the fact that parabolas have symmetry, I'm going to assume that this height is the same as that height. And by symmetry, that means that this is the point 200, because it's 50 meters to the right of where the car emerges from underground. So 200, comma 300. So my domain would be all possible x values. That's 0 is less than or equal to x, less than or equal to 200 is my domain. Okay, we continue. The next question says, when is the roller coaster below ground? Now, you can just look at your paper, you don't have to draw this, but because you can't see the picture, I'm going to quickly sketch the graph. So this is the point 150, 0. This is the point 200, 300. And this is the point 0, 300. And this is the point 50, 0. Okay, so we want to know, when are we below ground? Well, this is the ground. So every time we're below that are these values. So this is when we're below ground. And it looks like, okay, the boundary of when we're below ground is when x is 50 and 150. So anytime x is between those boundaries. So we've got 50 has to be less than x, and 150 has to be greater than x. Should I allow for equality? Am I below ground when I'm at ground level? No, I'm not. We should not allow for equality. Okay, let's continue. The next question says, when is the roller coaster above ground? That is, for what values of the function, for what values of x is the function positive? Okay, well that's when we're above ground. So for what values of x is the function positive? Well, let's consider where our boundaries are. We've got boundaries at 50 and 150. It looks like if x is less than 50 and greater than 0, so 0 is less than or equal to x is less than or equal to 50, then I'm above ground. Should I allow for equality? Am I above ground when I'm touching the ground? It's not clear, and I want to be conservative, so I'll take away that part. But that's not the only answer, or let's see, it also works when x is greater than 150. I think strictly greater, because we're not above ground when we're on it, although we kind of are. I'll leave that up to you. Less than or equal to 200. All right. The key parts right here are that we're focusing on boundaries, and that our solution is either everything outside the boundaries, as in the blue part, or everything inside the boundary, as in the red part. And that's going to be an important thing to keep track of as we go forward. So where are we going with this? As a quick review, let's go over what these symbols mean for graphing inequalities, because we need to be able to do that. Equal to. Let's say I'm doing x is equal to 3. That's a closed circle at 3. To show you that that's the solution. Less than or equal to. X is less than or equal to 3. Well, 3 is part of my solution, but I can also include everything to the left of 3, because x could be equal, closed circle, or less. Closed circle. Okay, less than. Let's say x is strictly less than 3. Well, I'm going to do everything where x is less than 3, but since I can't be equal to 3, I need to have an open circle right there to show the whole world that 3 is not one of the answers. Open circle. Okay, greater than or equal to. X is greater than or equal to 3. Okay, I'll plot that. Is equality allowed? Yes. Fill in the circle. Everything greater or equal to 3. Let's do X is strictly greater than 3. Now, is equality allowed? No. X cannot equal 3, so I put a circle there so the whole world knows it's not one of my answers. Everything up until that. Now, what we did in the last problem was we solved a quadratic inequality. We didn't say we were doing that, but that's what we were doing. We were finding for what values of X a certain inequality was true. We're going to go through the steps for doing that right now. So this is our example. We're going to be solving this quadratic inequality. X squared minus 3x minus 5 is greater than negative 2x plus 1. Now, if you remember, up top here, we had two really important points. That was 50, 0, and 150, 0. Those are called boundary points. And the first step for solving a quadratic inequality is identifying those boundary points. And you do it by solving your inequality as if it were an equation. So I'm going to do that. I'm going to solve this inequality, x squared minus 3x minus 5, as if it were an equation, equals negative 2x plus 1. I'll add 2x to both sides and subtract 1 from both sides. That gets me x squared minus x minus 6 is equal to 0. If you factor that, you would get x minus 3 times x plus 2 is equal to 0. Using the zero product property, that gets you x is equal to 3 or negative 2. Now, you won't always use factoring to solve these. You should use whatever quadratic solving strategy suits the problem. Use whatever strategy fits the problem. Sometimes that could be the quadratic formula, sometimes it could be completing the square, and then taking the square root of both sides of an equation. In any case, it could be any of the techniques that we've had since chapter 4 and beyond. Okay, so once you get your solutions, which we do, those are the boundary points for the solution to the inequality. Once you have those boundary points, go ahead and plot them on a number line. So I'll be plotting negative 2 and 3. And keep in mind that we need to know if we're going to make open or closed circles on the negative 2 and 3. Now, if your inequality originally has equal to allowed, which we did not, but if we did, then we would use closed circles. If you have a strict inequality, which we do, we have a strict inequality, then you use open circles. So I have open circles right here already. What we need to do is, in our next step, we're going to select test points from each region created by the boundary points. So, for example, you might pick 4, maybe you pick 0, and maybe you pick, I don't know, negative 3. We're going to use these test points to check if our solutions are in the regions of our test points. So this will be region 1, and I'll do it first. And to test that, what I do is I plug them into my original inequality. You can't see it on the screen, so I'll write it again. My original inequality was x squared minus 3x minus 5 is greater than negative 2x plus 1. Okay, so I'm going to plug 0 into that equation. 0 squared minus 3 times 0 minus 5 greater than negative 2 times 0 plus 1. This would become negative 5 greater than 1, which is false. That's not a true statement. False. Okay. Then I'll do the next region. I'll call this region 2. And I'll be plugging in 4. So I get 4 squared minus 3 times 4 minus 5 greater than negative 2 times 4 plus 1. So that's 16 minus 12 minus 5 is greater than negative 8 plus 1, which is the same as a negative 1 greater than negative 7, which is true. Okay, oops, I'm sorry, everybody. I should have made region 2 over here, because that's where the point 4 is. This was region 2. Okay, now I'll do the last region. Region 3. So now I'm plugging in negative 3. So that's negative 3 squared minus 3 times negative 3 minus 5 is greater than negative 2 times negative 3 plus 1. That's 9 plus 9 minus 5 is greater than 6 plus 1. Okay, so that's 18 minus 5, which is 13, greater than 7. That's true. Okay. We've just figured out where the truth is going to be. This area is a bunch of truth in it, and this area has a bunch of truth in it. So we've chosen numbers on both sides of each boundary point, and we plugged them in the original inequality. And we evaluated each of the inequalities we created, noting which produce true and which produce false statements. This is key, and we're going to use it to answer the rest of our question. So now we're going to represent the solution in graphic and algebraic form. So I'll start with the boundary points. We had one at negative 2, which was an open circle, and one at 3, which was also an open circle. Now, if a test point satisfies our original inequality, then its region is part of our solution space. So on our number line, we're going to darken the areas where we found there to be truth. 4 was true, so everything in 4's region is true. -3 was true, so everything in -3's region is true. And 0 was not true, so nothing in 0's region is true. This is how you can show the answer to a quadratic inequality graphically. Algebraically, we would write the following. X is less than -2, or X is greater than 3. We continue. Okay, problem 9-50 says, the operational costs of the minor 49er amusement park are $300,000 per day. The manager for the park uses the function r of x equals 100x times 0.5x plus 5 to project the revenue for a given day if x people visit the amusement park. For part A, we're going to write a function that models the net profits of the amusement park for one day if X people visit the park. Note that net profit is the revenue minus the operating costs. So we need to do the profit, which is revenue minus operating costs. So the profit, I'll call it P of X, is going to be the revenue, which is 100 times x times 0.05x plus 5 minus the operating costs, which is $300,000 per day. Part B says, for what numbers of visitors will the park have a negative revenue? So we need to figure out when will the revenue equation be less than 0. So 100x times 0.05x plus 5 less than 0. Well, we have steps to solve this. Step 1, find the boundary points. 100x times 0.05x plus 5 set equal to 0, and I'm going to use the zero product property. X is equal to 0, or this one's a little harder, 0.05x plus 5 equals 0. I subtract 5 from both sides. 0.05x equals -5. Divide both sides by 0.05. So x is equal to -100, which is nonsense because I'm never going to have -100 visitors. So this is the only boundary point I care about. But still, we'll do all the steps. So our boundaries are at 0 and -100. And I'm going to test the regions. Okay. Am I really? No, I'm not. Look, students, do all of the steps, except for when you don't have to. In this case, you really don't have to, because I know that X represents the number of visitors. I'm never going to have a negative number of visitors. I'm always going to have 0 or more. Now, if 0 is the boundary point, and it's asking for when will the revenue function be less than 0, then I'll just test values around 0, but I don't think it makes sense for it to be negative. I'm just going to test it anyway. Okay, here we go. Let's plug this in. 100 times, I'll test -1. -1 times 0.05 times -1 plus 5 equals 0. That's negative 100 times some positive number. Sorry, I shouldn't have done equals. I should have done less than 0. And it's true. So I'm negative here. So I think I'm going to be positive here. Let's do 100. I'll do 1 for the other one. Times 1 times 0.05 times 1 plus 5. These are two positive numbers. Positive times a positive. Is that less than 0? No, it's positive. So it's going to be a positive number. False. So it seems like I'm only negative in the revenue if I have negative visitors, which is never going to happen. So my revenue will never be negative. As long as I have a visitor, my revenue is positive. Does that mean I'm always going to make money? Let's check the next question. When is the profit function going to be negative? So the profit function is a little bit different. That's asking when is 0 less than 100x times 0.05x plus 5 minus 300,000. Okay. All right. That's 0. Treat this as an equality. Equals 5x squared. I'm putting this into standard form. Plus 500x minus 300,000. And I'm going to use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. But actually, I'm just going to plug it into a quadratic formula calculator. And I plug that in, and I get my boundary points. X is equal to 200 or negative 300. Okay. So now I'm going to test these regions. So negative 300, open circle, 200, open circle. I'll check 0. What happens if I plug in 0? Let's see. It's 0 less than negative 300,000. If you plug 0 into your equation, then you'd be plugging 0 here and here. And I know that this goes to 0 when it's 0, so it just reduces to negative 300,000. And negative 300,000 is not greater than 0. But I made a mistake in my original equation, and I should have had my inequality symbol facing the other direction. Because I want to know when the function is negative. So this is actually true. And I know that if the middle region is true, then the outside regions are going to be false. So I know this is going to be my solution, but let's solve it anyway. Let's also pick, I don't know, maybe 300 and plug that in, and negative 500 and plug that in. So if I do negative 500, that's 0 greater than in negative 500. That's 100 times negative 500 times 0.05 times negative 500 plus 5 and minus 300,000. And what I get is a number that is larger than 0, so this is false. Yeah, if your solution region is in the middle, it's going to exclude the other sides. So this is just going to have answers in the middle. So that means if x is less than 200, then I'm going to lose money. If I get fewer than 200 visitors to the park, I'm going to lose money. Okay, part D asks, how are your answers to part B and C the same? Question mark. Different? Question mark. So both problems talk about how many visitors I need in order to not have negative income. But profit and revenue are different types of interpreting income. Essentially, you can lose money even when your revenue is positive because of operational costs. This is a taste of the kind of math that I think you have to do if you study business. Let's continue. 9-51, Fog City. San Francisco is well known for its fog, which is very thick. Low-lying clouds that hide its hills. One foggy day, Penelope is practicing kicking a football. Once she kicks the football so high that it disappears into the fog. The height h of the ball in feet can be represented at time t in seconds by the equation h of t is equal to negative 16t squared plus 64t. The ball disappears into the fog when it is 40 feet high. Part A asks us to write an inequality that represents the times during which the ball is not visible. Solve the inequality and represent our solution algebraically and on the number line. Okay, so we are interested in when it's not visible, which is after it disappears. So whenever our function h of t, which is negative 16t squared plus 64t, is greater than 40 feet high. Now we're going to solve it. So to do this, solve the inequality, represent our solutions algebraically in a number line, I need to find my boundary points. So it's negative 16t squared plus 64t, set it equal to 40, and I solve this equation, which is negative 16t squared plus 64t minus 40 equals 0. I'm going to use a quadratic formula calculator, which gets me the boundaries are t is equal to 0.775 or 3.725. Okay, now I'm going to figure out the solutions region. Now, students, you can use your boundary points. That's a great method. But look, I'm asking you to try to get out of that whenever you can. I'm going to solve this visually. I know I've got a parabola. And I know I'm trying to find when I'm above a straight line. So that's everything in the middle of the 2 points of intersection. So my solution is here. Now, I am invisible every time I am 40 feet works. So that's my inequality should have the equal sign in it. So this should be my answer. 0.775 is less than or equal to t, which is less than or equal to 3.225. That's the answer. Okay, next question. How high does Penelope kick the football? When does it reach its maximum height? That's basically asking me to find and interpret the vertex. So I'm going to read this as find and interpret the vertex. So to find my vertex, I could use negative b over 2a, but I personally think that it would be easier to go between my x-intercepts for my original height function. So I've got h of t is equal to negative 16t squared plus 64t, which is the same as negative 16t, I'm just going to factor it, times t, what's 64 divided by 16? Minus 4, which gets me x-intercepts at 0 and 4. 4, 0, and this should have been at 0, 0. That's what my graph looks like. Okay. And then I'm going to go exactly between them to find the x part of my vertex. 0, 4. So the x part of my vertex is equal to 2. And now I need to find my y part of my vertex. So y part of my vertex is going to be if I plug 2 in to my equation. So that's negative 16 times 2 squared plus 64 times 2, which is negative 32. Oh, sorry, 2 squared is 4. Negative 64, because it's 16 times 4, plus 128, which is 64. So my vertex is 2, 64. And in context, that means the ball reaches a max height of 64 feet after 2 seconds. Period. Okay, we continue. 9-52. Consider the quadratic inequality x squared plus 2x plus 1 is less than 4. Solve for the boundary points. All right, we've had a little bit of practice with this. Let's go. X squared plus 2x plus 1, setting it equal to 4. I'll subtract 4 from both sides. Gets me x squared plus 2x minus 3 is equal to 0. This I can factor. I need to multiply to negative 3 and add to 2. That's what? Negative 3 times 1? No. Positive 3 times negative 1. Yes. So then if I factor this, I get x plus 3 times x minus 1 is equal to 0. Is that right? Yeah. Okay, good. So my boundary points are at x equals negative 3, because the zero product property causes that to change sign. That's like x plus 3 equals 0. So that's x 3 and x minus 1 equals 0 gives us x is positive 1. So my boundary points are at x equals negative 3 and positive 1. There are 2. Okay, place the boundary points on a number line. How many regions do we need to test? Okay, negative 3, 1. Okay, so we're supposed to say 3 because there are 3 regions that need testing. Region 1, region 2, region 3. I claim you can get away with testing just 1. If the answer is in region 2, then it won't be in regions 1 or 3. If the answer is in regions 1 or 3, then it won't be in 2. The 2 options for answers are negative 3 and 1. Let's see, we need open circles. Open circles. This might be the answer. Or this might be the answer. And logically, you can figure that out just by testing 1 point. But we're going to test all 3. Okay. Actually, I refuse. I'm just going to test 1. Okay, so I'm plugging 0 into my original inequality. I'm testing region 2, and then I'll circle which of these the correct answer is. Let's see, what was my original inequality? Oh yeah, x squared plus 2x plus 1 is less than 4. So I'm plugging in 0. 0 squared plus 2 times 0 plus 1 is less than 4. Okay, that reduces to 1 is less than 4, which is true. So this region right here is where all my answers are. This is the answer. This one, not this one. Great. So we test each region and determine which ones make the inequality true. Identify the solution algebraically and on a number line. I am going to go ahead and do that. So we've already tested this area. Region 2 is true. And I kind of know that that excludes the other ones, but let's test them anyway. How about I test, I don't know, negative 4. Negative 4 squared plus 2 times negative 4 plus 1 is less than 4. It's going to be 16 minus 8 plus 1. It's going to be 8 plus 1, which is 9. 9 is not less than 4. False. No solutions right there. Okay. Let's test this region. I'll check the number 2. 2 squared plus 2 times 2 plus 1 less than 4. That's 4 plus 4 plus 1, which is 9. Less than 4, which is again false. So we were right. Okay, showing this graphically, we've basically already done it. I'm just going to erase the false and true stuff. And then this is, oops, sorry. This is us showing it graphically. Algebraically just means that we're going to write this with symbols. Now, some of you have learned to write this with greater than or less than signs, but some of you have learned interval notation. You don't have to know interval notation for CPM, but it is something that exists and other textbooks use it. So I'm going to show that to you as well. The answer can be written either as negative 3 is less than x is less than 1, or negative 3 to 1. These two statements mean the same thing. CPM textbook uses this one. Okay, let's continue. Last page. Now we're going to solve each inequality. Let's go. Step 1, boundary points. X squared plus x minus 12 equals 0. Okay, I'll factor that. Multiplying to negative 12, adding to 1. It's going to be positive 4 times negative 3. That gets me x plus 4 times x minus 3 equals 0, which gets me the boundary points of -4, and +3. Is this an open circle or a closed? Open, because it's a strict inequality. Okay, and you could test every region, but I'm just going to test the middle. And if it's not the middle, then it's the outside. So I'm going to test 0. So that's going to be, let's see, I'm using x squared plus x minus 12 less than 0. Have to plug it into the original equation. Okay, 0 squared plus 0 minus 12. -12 less than 0 is true. So this is where the solutions are. Okay, so on the number line, it looks like this, and algebraically, you would write it as -4 is less than x is less than 3. That's our answer. Next problem. -2x squared plus 10x greater than or equal to 7. Let's find our boundary points. -2x squared plus 10x. I subtract 7 from both sides, and I use equality. Okay. I wonder if this will factor. I sort of don't think it will. Let's see. Is there anything that multiplies to 14 and adds to 10? No? Cool. I don't like the quadratic formula very much, personally. I'm going to complete the square. I'm going to divide both sides by -2. That gets me x squared plus 5x plus 7 divided by 2 is 3.5 equals 0. Okay. I break 5 in half, I get 2.5x, 2.5x, x squared. That means that in my equation, I'm going to have x plus 5x plus, what's 2.5 squared? 5.25? Okay. 5.25. And then I have to sorry, this should have been x squared. And I have to subtract that 5.25 so that I'm not changing the value of my equation. And then I have plus 3.5 equals 0. This part is my square, x 2.5, x 2.5, and can be rewritten as x plus 2.5 squared. And then I have that minus 1.75 equals 0. Okay, I'm going to solve this by adding 1.75 to both sides. That gets me x plus 2.5 quantity squared is equal to 1.75. I take the square root of both sides. I get x plus 2.5 equals the square root of 1.75, plus or minus. And then I subtract 2.5 from both sides, and I get x is equal to 2.5 plus or minus the square root of 1.75. And from that, finally, I get that x is equal to, sorry students, I should have had minus 2.5 because you have to subtract it from both sides. Anyway, what I end up with is x is equal to -3.8 or -1.2 approximately. So I'll plot those. -3.8, -1.2. And let's see. I'm going to test 0. So if I plug in 0, then I get negative, with my original inequality, -2x squared plus 10x, and I'm checking if that's greater than 7. -2 times 0 plus, 0 squared times plus 10 times 0 greater than 7. This reduces to 0 greater than 7, which is false. So 0, which is like here-ish, is not part of my solution region. Therefore, my solution is going to be between my boundary points. Should it be open or closed circles? Closed, because equality is allowed. 0 is not part of my solutions, so my solutions are everything between those points. Now you could pick points on either side of each of them, and that's what our instructions tell us to do, but logically, if you know that the solution is either going to be like this or like this, you really only need to pick one point to check that. And frankly, if I'm doing this in my head, and I'm doing this on my own, I always pick 0. It's the easiest thing to plug in. Okay, next problem. Last problem, yay! Okay, this is not quadratic, it's absolute value, which is just a little bit easier than quadratic, if you know how to do it. Now, I know that if the absolute value of x were greater than 7, then that will be the same as saying x is greater than -7 or x is greater than 7. But I don't have that. I have x minus 2. But look, it's basically the same. That says that x minus 2 is greater than, oh, we're doing boundaries first, sorry. I should say equals. It's equal to 7, or x minus 2 is equal to -7. And then I solve both of those for x. So let's do that. I'm going to add 2 to both sides of each equation. That's x is equal to 9, or x is equal to -5. And we have to test these 3 regions. Now, again, I know that I'm either going to be outside or inside. So am I really going to check 3? No, I'm not. I'm going to test 0. Test. 0. Okay. Is 0 minus 2 greater than 7? Well, is the absolute value of -2 greater than 7? No. 2 is not greater than 7. False. So 0 is not in my solution set. That means my solution set is everything on the outside of these boundary points. Should I do open or closed circles? Open. Equality is not allowed. And I want everything that's not in the middle. And that's the answer. All right, students, I hope that you are able to make sense of these. Let me know if you have any questions, and I'll see you next time. Thanks.